first presentation is coming from Konika Minolta, Ukraine. Igor Panivko, who is both finance director but also managing director of the company in Ukraine. He's going to share with us his view on dynamic and interactive sales planning based on algorithmic model. And before we start, just a brief introduction of Igor's background. So, very unusual profile for CFO, finance director. So it's both finance and data science. Igor, you just recently received your master degree from Master of Science in Data Science from University of Wisconsin in the US. So year 2018. So you studied at the same time while you were managing the company. So it's very impressive achievement. At the same time, you have Master of Science in Finance and Accounting from Kyiv University. Several Microsoft certifications, including deep learning. So you can see that the new generation of CFOs, those that are interested not only in finance but data science. Igor, you're welcome to start this meeting with your presentation.
Hi, everyone. Thank you, Larissa, for such an impressive introduction. I'm really will be happy to share with colleagues about my experience in harnessing data in day-to-day finance tasks. And I'd just like to add to the background that the reason to go dive deeply into data science was to solve most of challenges typical for finance function, which took so many time from me and from my colleagues for many years before. So I tried to really put some models, algorithms in place and to automate as much as possible. The project which I will be talking about is looks quite complicated, so I'll try to provide you some details why it's named in such a way. And the algorithmic model which we used in sales planning was possible because we have concentrated on the overall description of our business model and embedded analytics and machine learning algorithm inside of it. So let's go through the background of this project, which took in time for several years. And these are the challenges which I think everyone is facing in FP&A tasks, as sales planning is quite tedious for every company as far as I know. And for us, it was also a huge challenge to make it clear, understandable without spreadsheets, with very quick creation and deployment in how IT guys say in production, and at the same time it should have been very reliable and flexible, which are contradictory goals. So all these tasks were behind the general idea of building such a model which could be used and shared throughout the company, and we could work together on better business goals rather than data processing tasks. Next, please. So typical sales planning scenario which we are using in our company throughout all countries looks in the top-down manner. So we get targets from the headquarters, and then we translate the general growth targets to our business units and products, and connect it to drivers and the operational KPIs relating to every segment of our business. As we are a service providing company, we have many business lines which are quite complicated and usually many maybe tens or hundreds of Excel file spreadsheets were used to prepare models and integrate it into one financial plan for the whole company. So we were not using the bottom-up approach as probably many of the corporations are somehow target oriented. So I think top-down scenario was quite typical and could be used as an example for other companies to apply in future for the same strategy if someone decides to use it. So the main idea is that we connect everything from global task to concrete specific task of each division of each service or business line in the company in the algorithmic way, by some percentages, by some in some quantitative manner that allowed us to make mathematical description and to create interconnection between various dimensions of the business in one model. And next, please. And these are the typical steps which we used before for creating models. So we grab the data from ERP systems or data sources, whatever they could be, through some data requests, from SQL requests, through manual filling in of the spreadsheets. And afterwards, we created models in Excel files. And there are quite often we faced with situations where data were not validated and were distracted from reality, forgotten, as typical for any Excel model, which may lose some connection to reality, and the business logic cannot be very much transparent to all the participants. So to overcome, yes, next please. Next please. To overcome these challenges, we have developed a so-called sales model as a solution, where we put as description of our logic of the business. As you can see, the first such example is simple as quantity times prices. This is very simple, but of course it's much more complicated when we connect many of our products, which we have hundreds of, and create some scenario how we create a sales model. So we put those logic algorithms in scripts, in coding. So I was myself participating in and creating such scripted models. We tested on real results, on real data examples, how they work. And those scripts, it was Python language which was used, but it can be any language, a programming language which you have access to. It can be Java and can be another language. It depends on the resources. These logical descriptions in scripts were connected with predictive models, which were developed for those kind of planning where we usually used human intuition approach. That means that, for example, spreadsheet files were filled in by some sales guys who projected on their own their logic of sales, but the purpose was from our side, from financial team, to grab that logic from their minds and to try to select the algorithm which would in the best way fit the logic of sale planning. In further slides, I will show you how we try to solve this problem, and afterwards we integrate it into the one model, which is a multidimensional cube It's an OLAP cube developed on SQL Server platform of Microsoft, so-called business intelligence stack offered by Microsoft, but it can be deployed on any technology. SAP, Oracle, IBM, does not matter. So Larissa already switched to the next slide, which is describing how we developed predictive sales or machine learning approaches. So the task was not obvious which models will work or not, or whether at all we will select some models for development. So we've picked up the most impacting products and business lines and tried to analyze the connections in mathematical way to say correlations between them and find those which have quite strong connection. Mathematically, it's a coefficient of determination, which should have the figure exceeding 0.5, as you see from the slide. And this was a very simple, but it turned out to be very productive and useful algorithm to use. As I know from other projects which I tried in data science and machine learning, linear models, which are based on simple correlation logics, are very robust against volatility or changes or some unpredictable behavior in time. They are much more stronger than sophisticated models which can be used otherwise. So they proved for us as well. And we, after testing and validating our linear models based on correlation, we saved them in special format for further use in predicting scenarios when my colleagues from other business lines try to make some projections and scenario planning. They were directly invoking those algorithms and got results in front of their eyes through spreadsheet tool. In cases where linear models showed poor predictability or poor strength of determination, then we switched to other techniques called time series predictions, which is also very popular in finance world. I know that, for example, in stock predictions, they are extremely powerful and used across the industry, but maybe not so much penetrated into common corporate finance practice. But in terms of predicting of products development of sales in time series can be very helpful, and we proved that as well. So for us, we tried a bunch of time series approaches and finally landed with HOLT-WINTERS models, which in other words, it's called as exponential smoothing model, which are quite simple and robust as well. So we put it in combination with our linear models for behavior of our products, and they showed the minimum prediction error, which is also a common term for linear model. Sorry, too much mathematics, but this is how we used it. So the main idea from this slide is that very simple algorithm, which are very well known from basic statistics courses or predictive analytics or used in basic machine learning, can be very useful in finance as they replace human intuition and much more reliable in applying them to figures than just spreadsheets models used by someone who can make a simple mistake in files. So next, please. This is how time series works. Actually, it's a standard approach to predicting. So in our model, we use the last 3 years. As you see, is more or less common pattern of the data behavior. So I took it from my original workbook where I tested models, and the result was pretty robust. Nowadays it's 2019, and I can give you feedback that already 5 months afterwards our planning, so the model shows quite accurate results according to this planning, and it has caught the trend very well and seasonality, as you see. And before that, before the year 2015, the data behaved not maybe in the same pattern, so we slashed that kind of period. We did not use it at all. So it's also important that if you try to use the predictive algorithm, you really concentrate on the most common pattern of data behavior, and then try to apply it to business logic. And if nothing happens extraordinary, the models are very robust. It saves a huge amount of time and can be used repetitively throughout the company. Next, please. Uh, no. So the main idea is that the predictive modeling is not used by me, for example, as one person. So the models are saved and deployed to the special server where the data model is stored, and the data model has APIs to various front-end tools like web service, so web pages and Excel worksheets are connected to the data models through pivot table interface. So that's the meaning of the interactive planning. So we have a general structure with how it works. So in the beginning, the sales guys, for example, or managers of some department, of some business line or department, enter the basic parameters which they would like to play with for their scenario planning. They can do it in Excel spreadsheet and click and run the model. So the Excel sheet which they open is connected to the model and to the scripts. So as soon as they make an input, the model starts calculating. So it takes around 30-40 seconds up to 1 minute to launch the predictive algorithm to bring results. So the results are brought back to either tool, whatever you are using. So we were using two of them, also based on Microsoft. It's Power BI and Excel pivot table. And immediately the business line managers can see some projections in their individually built pivot tables for their department, for their business line or geography, and may change again new parameters, new assumptions into the model, and get the new results. Thus, we use Excel as a front end and the result window. So Excel for us is not the calculation tool or model creation tool. It's a tool of getting data in the very typical way which people got to use to work with, and get back in result in the same way. So actually they don't understand how the data flow and what's going on behind the curtain. So such a way we reach quite significant progress in analyzing various approaches to business modeling. And the main point is that uh, the focus in planning is shifted from finance to those who are responsible for certain business directions, and finance is guiding their colleagues how to better to um, manage the model, maybe improve, maybe to um, coordinate some adjustments, and actually maybe to interpret results. So in the end, we see that actual results are compared with planned. and final planning results and targets are stored and will be used for targeting and evaluation of performance of business guys throughout the year. So in the end, it will be performance measurement tool as well. Yes, next please. So what we really are proud of, that we connected some intuition um, which we used before with business mathematics, and created an overall business model for our company. So our intuition is concentrated with more with business development, which outside the model, and model helps us quickly processing um, and prototyping some ideas which come to our mind, and we can really develop some new scenarios of our business behavior. So technologically, it's maybe a bit complicated. I cannot bring you all the details because there are stack of technologies. There are scripts written in Python languages. There is a technology of SQL Server. There is a multi-dimensional cube. There is an all-up model and special language of data inquiries from multi-dimensional cubes. So all this is connected, and it's a way of how we can connect um, past and future, as you can see from the slide, and make a planning visible and comparable to the past results, and compare also our so-called future or predicted future with our current or past results, and work with this interactively. Yes, please, next. And next, please. So the key benefits is a quick prototyping and simulation. Prototyping simulation of the model. If a new business model arises, so we can simply add it to the overall model and prototype and use it. So it's not static, it's dynamic. So whatever business logic is changing, we know how it works in general design, and we can be very flexible in redesigning whatever process we wish, because the architecture is modular. It is based on some modules, and which can be easily replaced by IT guys. So the second benefit is that the results are very solid and validated. If the mistaken error is contained in the model, then of course it's a drawback of the model itself, but no human mistake can be the cause of any trouble. And the third benefit is, of course, real-time calculation, so no latency for calculating in Excel files, transfer it somewhere else and waiting for results, how it is robust or not. So we can see immediately what we get as final results, and even use our intuition to feel whether it's realistic or not. And as I mentioned, easy redesign is also a key benefit, as we can reprototype whatever we wish. The only challenge, as you see in the bottom of the slide, is getting data engineering modeling skills, which are not easy to find. So I was myself managing such a project, and I'm really proud that it worked, and finally the result of predictive modeling machine learning is the biggest challenge is how to deploy it. how to use it in real life without too much human intervention or individualized Excel or any spreadsheet type of information. So that's the key point and benefit of this whole project. Just to share with you the outcomes, it has been realized in several companies. So I tried to use several approaches in Ukraine and Russia. So it worked in both ways and just in different configurations. So I think the basic idea is um, model should be the way of descripting business logic and put it in somewhere for shared use, and attaching machine learning or predictive algorithms as part of the model. So in my vision, predictive technology is just the tool for overall data analysis or data modeling of the business.